All right, so now we're live with the on-campus and online students here. So up until this point, and we've only written a couple of programs, and hopefully you've worked your way through the material, and we've done some interesting things. You've done the, car salesman program, so you could work with numbers, you can work with letters. You kind of have an idea now for inputs. And remember, one of the tricky things with inputs is the inputs always come in as a string, and so we have to convert them back to a numeric value. And that tends to be things that people tend to forget. Make sure you've went into the solutions, because I do have the sample solution for Chapter 2, at least one very easy to utilize version of that. And make sure you look at it and go, hey, maybe I could have done this. I could have done something different. You're going to see that we're going to start posting our codes in the discussion board a week afterwards so that we can start to share, because quite frankly, 30 students in a class, we should have 30 different solutions to a lot of these problems. There isn't one set right answer for these at this point. We're starting to diverge and become your whatever flavor, whatever you have in terms of your own input starts to reflect on that. So one of the things we're going to do, so I'm just looking at the very first page of Chapter 3, and we're going to look at how do we start to create random numbers, because they're very, very useful for a lot of strange things. If we do any kind of gaming, we may want to just have a random number for some other use. Maybe we want to create a card game. We're going to look at if statements and those else statements. How do we create conditions and make choices? So until now, we didn't have any way to say, I bought a car, do I want the rust proofing, yes or no? Do I want, so we haven't yet got to that point where we could ask those questions. So now we could go back and recreate that program and do something a little different with that in terms of those questions. Though we do have something called the elif we're going to talk about. In other words, we have kind of a case statement if you've used other programming languages, kind of like a case switch or something very similar. And then how do we use a loop? So all of these programs are interesting, but even a program like the one we created to price a car. Well, generally we want the entire program in some kind of loop if we think of it abstractly, because we want to get to the end and say, do you want to exit this program or do you want to run it again? So even that loop of the entire thing. So even if our program is only a set of selection structures, we can have that ending piece to some way to loop back and recreate the program. The other thing, those loops give us a lot of power, because I don't like to repeat and do things, and I'm lazy. So those loops let me do things repetitively. So some of you may be on a sports team. If you could get somebody to repetitively run those laps around the track, well, we can't do that. But in programming, we can. Once you create that structure, you can loop through and recreate things over and over and over again. And due to those things like polymorphism that we talked about, in other words, we modify the program so it can accept multiple different types of inputs. And based on those inputs, it creates an output. You might be able to create a program that'll take in either numeric data, it takes in text data, and it does something different with each different type of data. So the first program we're going to look at is something called a guess my number game. So guess my number. You guys have all played those. Pick a number through 1 through 10 or something to try to figure out, who has to do some hideous task. Well, we're going to look at it from the same standpoint. So this program is going to have a loop, because we need to be able to loop through the structure. It's going to have some way to take in input. It's going to have a comparison so that we know that that loop ends if we have an input equal to what our assigned value is. So it's got a lot of these pieces that we want to look at. So on page 50 in the textbook, as my microphone tries to fly away here, we're going to look at how do we generate a random number. So if I go into this folder full of all kinds of content, you're going to see we're going to look at a program called Craps Roller. Odd name, but it describes what we're going to do. And so I'm going to open this Craps Roller. Now remember, to be able to get this, you have to extract that entire folder. I've already done that. I'm going to then edit this with that idle program. So I can right-click and edit it in idle. Now, honestly, I could actually do this program. Let me turn that volume down just a smidgen. I think I'm overloading the microphone. Okay, sorry about that. All right, so I'm going to look at this Craps Roller program because what we're going to very first do is we're going to generate a random number. And generally, so if you've played craps, you throw 2 dice out. So we need to generate a random number and we need to create that for each dice. So how many sides are on a dice? Okay. So we're going to look at how do we create them. All right, so we first have to do something a little strange. So remember I talked about all those libraries that we have in Python? Well, one of them we need is the random library. And so this line here allows us to import that random library. So it doesn't do anything else except goes out and grabs that library and says, hey, I'm going to grab the random library. So you can see that on the bottom of page 51. So that random module, and you're going to see we're going to grab other modules later on, but for right now, we just grabbed the one random thing. So we now, because we've got that random function, we can now look at getting a value. And so here we're going to look at one method to get a random number. And so we start with this idea of that function random. So we're assigning the value to die1 or dice1, whatever we wanted to call it. And we're using that random function. And remember, we use that dot notation, and we can add some additional controls. And so in the case of the random function, we're going to do the first dice using something called rand integer. So it returns an integer. And that integer is between the values of 1 and 6. Well, that's a pretty handy, easy way to do that. So on the second dice, we're going to use a variation. Now, the reality is I'd use the same method for both of them, quite honestly. But to show you a different method, here we're using one called rand range. And rand range says we're creating a range of values that are 6 numbers in there. However, I'm getting a set of random numbers there's 6 of them in a pool. But what do I have to do? Notice I have to add the +1 in there. Why would I need to add the +1? Because of 0. So when I tell it to give me 6 random numbers, it's going to start at 0 and go to 5. So we add a 1 in there to make that equivalent then. All right, so all we do then is we're going to total them up. So we have a third variable. So I'm going to go run this and see if it really does run. And we can always model, these. So you rolled a 1 and a 4 for a total of 5. Oh, okay. Well, that's interesting. So we can change this just to see what happens. So if I change that to an 8, we can run it. And it's going to say, do I want to save it? Yes. You scored a 5. So we could run it multiple times until we see what. And oddly, it's going to give me all low numbers as soon as I do that. Interesting. But we can change that at any time. And we could see the result of if we took off the +1. That gives us the beginning of a dice program. So our book on page 50 and 51 and 52 starts talking about these two different functions, or the one function with the two different conditions. So we have that module called random. So we have the rand integer function. So that dot notation we're going to see more and more and more. So quite frankly, this is probably the easiest way to create that. So if any of you have played Dungeons and Dragons, there's even some 20-sided dice. And you could do something like that if you wanted to. The rand range gives us a value, which is almost always a positive integer. So because we start out with 0, you get the same thing. So this is our very first beginning. We've now created a dice game that lets us play one roll of the dice. So I now created one that's got 20 sides. So I rolled a 17 and a 5. Well, you could use this program if you're going to go play Dungeons and Dragons and you forgot your 20-sided or 18-sided or whatever sided dice. You could do this. Well, I'm going to close this. Well, first I'm going to do this. Save it back or I'll forget about it. I'm going to save it. So the other thing that's kind of handy, these modules give us a very quick way to create our own program. So if I wanted to change something in here, I can use these as little cut and paste modules. So I want to make sure you're aware of that one. So the next thing we're going to look at is the if statement. And the if statement gives us a way to make decisions. And decisions are pretty important for us to utilize. So on the bottom of page 53, we start looking at that idea of an if statement. And so if I scoot over to page 54, you can actually see the code. And so what I'm going to do is I'm going to open up my craps roller again because it's as good as any program we're going to grab. And I don't need the import function. And I don't necessarily need this, but what I'm looking for is I'm lazy. I don't want to retype that input statement on the bottom. And I could change any of these pieces I want. So I'm going to put in a variable. I'm going to say password, if I could spell password today. And we're going to assign it a value, and we're going to assign it an input. So I'm going to say input, enter your password. So we've got an input statement, and it's going to say enter your password. I'm going to create a very quick if statement. So if password. Now, Here's where one of the things that it's easy to forget. So when I do these logical conditions, Python makes it fairly clear which is an assignment statement. So in this case, the singles equals is an assignment. So I'm assigning to password whatever the input is. In this case, I'm asking, is it equal to? And so we use a double equal sign. So we're going to use something very silly. And then notice our punctuation. And that's the other thing that is very, very easy to miss. So if you forget that colon, it's not going to work correctly. And notice when I put that colon in and I hit enter, it jumps over a tab stop to show me that then it's a piece of this if statement. And I'm going to say print, gosh, I can't type. And again, print is a function, so we're putting it inside of here. You can access the world now. Okay. Now. Okay. Make sure you watch this and start working on these.
This is in the documents, right?
Yes. Yep. Yep. All right. So we now created a program that's going to ask you to put in a password. It checks that password against a known value. Now, the reality is, are we ever going to put a password directly in our program code like this? No. But it gives us a way to look at this as a sample. So I'm going to save this now. And I'm just going to save it as, well, anything. I'm going to call it my, no, I just saved it over craps roller. Ah, that's good. Ah, well, it'll run. So I'm going to run this module. So enter my password. And notice I didn't get access. So I'm going to run it again. It says enter my password. And notice now it actually executed that piece inside that if statement. Now, in fact, we talk about passwords and security and cryptography and a lot of other things in a security class. And on the bottom of page 54, there's a really quick statement about that. So these if statements are pretty easy to do. They look very, very much like what we did in the pseudocode. And in fact, if I wanted to, I'm going to copy this. And notice I stay in that indented area. And I know this is silly. I'm just using it to show you that all of these things that are indented are going to execute if this if statement. So in other words, that's our indented clause for that if statement. So if I would just save this and run, and I guess the right password, it executes that entire block. So we could put anything else inside of there we wanted to. So on page 55, we look at the comparison operators, and it talks about that double equal sign. There's a chart, which is very handy on the next page, on page 56, that looks at all of the comparison operators we can use. So in this particular case, we're matching up an equal sign. No, did I just kill that? There we go. Sorry about that. So we're matching up an equal sign. So we're matching secret and secret. a lot of these are useful for number functions, so the greater than or equal, the greater than, the less than, and then the not equal to. And so this is different than what I was showing you in pseudocode, because in pseudocode, most of the time what I use, and it's just out of habit, so for me, I tend to write as not equals. And it's one of the frustrating things when I'm writing in Python. I will do this, and what I really needed to write is that exclamation mark equals, and that means not equal to. The other thing that I am very bad about doing, and so you might want to just highlight those, is it's the greater than equal, not the equal and greater than. And so sometimes, for whatever reason, I want to flip those around, and I won't catch them in the code because to me they look like they're correct. So there are things that will go wrong or can go wrong. So if I put in this, so we know that that is a text string, and I said I wanted it to equal to 123. Well, Python is smart enough to go, well, what are you doing here? So let's run this. Enter your password. Well, normally it would do that. Hold on. It should give me an error condition. So notice it didn't compare those two. So I put in 123, and I have 123 here. So in general, we'll get an error condition, but for whatever reason, it's deciding not to cooperate with me and show you that big giant error message. We can't compare directly or make a logical assignment to numbers and strings directly. Now we can convert strings to numbers or numbers to strings to make some comparisons. So indentation is the key to these blocks. Well, if we can do an if, we can probably do an else. So in other words, I'm going to go back in here and put in secret again. So if I can do this, I should be able to also then say, if this condition is not true, so this all happens if a condition is true, how do I create something that happens if it's not true? Well, I can do that through our phrase else. So else you don't know the password. A security guard is on the way. So it's pretty easy here. We can run this. So let me file save. So I'm going to run, and I'm going to guess the password wrong. And notice it then executes the else clause, but not the if clause. So it gives us a quick, easy way then to make decisions and statements. Just because that's bugging me. So we can create else and if. And again, as long as it's in that block. Now there's some rules in there you might want to read about text and tabbing that you're going to find on page 58, so make sure you've read those. Or on, excuse me, on page 56 about indentations. So we can do an if, we can do an else statement. So if something's true, if it's false, we can make comparisons. Well, there's one other piece we want to look at, something called the elif. And the elif gives us the ability to look at multiple conditions at once. So instead of having to nest if, then, else statements, we can cheat something a little bit different. So I'm going to close this. Nope, I don't care. And I'm going to open up one called Mood Computer, and I'm going to edit it so I can look at it. And so the first thing I'm going to do is I'm going to run this just to see what it does. So it says, I sense your energy. Your true emotions are coming across my screen. You are happy today. Okay. Well, let's run that again and see if it gives us the same answer. I sense your energy. You are angry and unhappy today. Well, so this combines a couple of things. One, it's got what we call this ASCII art, which we had talked about earlier. Now, yes, it's cheesy, but what we're looking at is a couple of things. We import a random, so we're importing that random library again, and we set something called a mood. So a mood is a random number between 1 and 3. So there's 3 possible conditions. So if we just used if, then, else statements, we would have to create a nested if, then, else. So we'd ask for condition 1, else, and then have an if, then statement inside of that else statement. Well, elifs let us do something kind of interesting. We can create multiple conditions. So we create an if statement. So if mood is equal to 1, and I noticed we had to label that as happy, it's going to print this statement. So our happy face. If mood equals 2, then it prints out our neutral. And if it equals 3, we print out sad. Now, we did put an else clause in there. So the else clause says, illegal mood value, you must be in a really bad mood. So it's kind of a catch-all to see if we have screwed up or messed up something at the beginning. So none of those should ever happen, but say we did something strange. We forgot and we thought we were going to put in 4 and we got screwed up and we forgot the 4th one. So I'm going to save this. And now I'm going to run it. And of course it won't run the first time, I'm sure. No. I'm going to run it again. Nope. At some point we're going to get the error module. Aha. So it got an illegal value, and so that else clause allows us a way to escape out of that. So it's just a error trapping loop so that we don't do anything strange. So our if statements, so we have, instead of just an else, we have an elif, and we could have another one in there. We could have an elif for 4, for 5, for 6. So it gives us a way to make multiple condition branching very, very easily. So those elifs give us a quick, easy way. That else gives us an error trapping. And we could change, so we could take this program and create it into a card game to guess, for example, now we've got enough details so that you could guess at the beginning, you could guess heart, diamond, spade, clubs, and it could randomly generate a value, for example, to do that. Well, all of these are pretty interesting. There is a chart on page 63 you might want to highlight. It talks about the if and the else and the elifs, so it gives us a quick overview of them. Well, those are all fun and games, and they're interesting. But none of this allows us to reiterate and go over and over and over things multiple times. And that is one of the powerful things that a computer can do that we are bad at, is doing things repetitively. So at the bottom of page 63, we start looking at creating the idea of a loop. We do things all the time in loops, we just don't realize it. So the one we're going to start looking at is this 3-year-old. And so if I flip the page to page 64, we're going to look at something about a 3-year-old simulator. So I'm going to run this. I'm just going to double click it to run. And notice now it just pops up in the black text window. This program simulates a conversation with a 3-year-old child. Try to stop the madness. Okay. Why? 'Cause. Why? I said so. So what you'll see is, until we get the key phrase with a capital because, it's going to keep running over and over and over again. And like a 3-year-old, it just keeps asking that question, why, why? So let's open it and edit in idle so we can take a look at it really quickly. So we have our print statements up top. It says, welcome to this world, blah, blah, blah. And we have a while loop. Now the first thing we do is notice we set that response to a null value. So we know that we know what it is going into this loop. So the while clause says while response is not equal to the phrase because with a period, exactly as it's spelled. We're then going to run this clause where we ask for input of y. That's all there is to that loop. So everything inside that while loop, as long as this condition is not true, then that's going to loop over and over and over and over and over again. So we can look at this and we could put anything we wanted to inside of this loop. If I wanted to run dice inside of that loop, I could do that. Notice I don't have that import random in here because we're not using anything random. All this does is show us that loop. So everything in this block here is going to execute every time this thing runs. So if I run it again, yes, I want to save it. Y. And it runs everything inside that loop. Now, because of the way these work, notice here I put in the correct phrase. I put in because with a period, and it still, though, printed out all of those statements. Notice that? So that's something you have to think about when we create these while loops, because it doesn't exit out immediately. It still executes all these functions one last time. So this gives us a way to create a loop. So this, we call this a sentry value, and we call that setting it, because if we had run this program previously, we don't know that that variable might not be already have a value in it. And so we set that equal to essentially a null value at the beginning before we run that loop. Otherwise, that loop may never run. So we have one issue. Well, we have several issues with loops, but one of the biggest issues is the idea of something called an infinite loop. And so an infinite loop means that we create a loop that we have no way to escape from. And so it's pretty easy to do. So, lowercase. So I could create a loop and if I don't have an escape clause, and so notice this loop, so I'm going to set counter equal to 0. So, and I'm going to put another print statement in there. Oh, come here. And I'm going to print counter. And what I want to see, now this loop should run 10 times. That's my intention, but I forgot to put in that increment to increase that value. So let's see what happens if I save and run this. Oh, wrong button. Invalid syntax. What did I do there? Oh. What did I do? Oh, I did forget my colon, didn't I? Duh. I told you I'd do silly things like that too. All right, so we'll run this again. Oh. When I deleted stuff, I'd left trash behind. Okay, go away. Okay. Now we'll try this again. Uh-oh. Because I didn't put in that increment statement, I have an issue. So let me stop this. Yes, I'm still wanting to kill it. So what I needed then is also a statement in there to essentially say counter equals counter plus 1. So in other words, each time it loops, that count will run up. So let's see if that works. Oh, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh. Okay. Now, there's some shortcuts, so I don't really even need to type all of that, because remember we've got some shortcuts to increment values. So I could actually just say, I think it is, counter plus equal 1. So I have a shortcut. Oddly, I tend to just type it out, counter equals counter plus 1. That's just the way my brain wraps around that a little easier. And so that gives us a way to count from 0 to 10. And if I wanted it just 0 through 9, or I could start up here, I could make that a 1, and then it would count 1 through 10. So we have to be careful about making sure we don't have those infinite loops. We have to have a way to get out of there, and it's amazingly easy to do. We forget, or we create, say I wanted to count 1 through 10 or something, and I put a greater than instead of an equals, and I can do those kind of errors pretty easily. So I'm going to close this out. So on page 67, we start looking at this program called the Losing Battle Program. So the Losing Battle Program you're going to find somewhere in here. Where is it? Losing Battle Bad. All right, so I'm going to edit it and open it up and take a look at it. So this program, it's going to be a demonstration of this infinite loop. And so the program itself is printed out on page 67 so we can look at it and what's going to happen. So I want to show one other thing real quick. So if I actually just run this program, so I double click it to run, notice it's just sitting there and cycling and cycling and cycling and cycling. I can actually do something called a break. So I can do a Control C, and that will exit out of that running program from the command line. If I run it this way, which runs it inside of that idle editor, so I run module, it does the same thing, and I can do a Control C to actually break it, and then wherever it breaks, and you'll probably see some kind of an error message when it breaks. But that gives us a way to stop that infinite loop. So let's look at why this has got an infinite loop in it. So we have three variables in here: health, trolls, and damage. And while health is not equal to 0, we add a value to trolls, and we take a value out for health. Okay. So while health is not equal to 0, well, we set health equal to 10 up here, didn't we? But do we take any value out of that? What's the problem? We take a value away, don't we? So we say health is equal to health minus damage, and we say damage is 3, right? So what's the problem as this runs? So the first time this runs, health is not equal to 10, because what is health equal to the first time it runs? Well, it starts out at 10. We don't take it off till here. So the first time it loops, it's equal to 10. Okay. So I'm just going to write that down. So the first loop, health is equal to 10. The next loop, it's equal to, well, 10 minus 3. And then it's equal to 4. And then 1. And then, oh, wait a minute. But does it ever equal 0? And in fact, your hero swings and defeats an evil troll, but alas, your hero is no more. So in each loop, we could actually add another print statement. So just so we see what's going on, we're going to print health. And so we're going to run. Yes, okay to save. And notice there, see it goes negative pretty quickly. It never is equal to 0. Yes, I want to kill it. So sometimes we add these extra print statements and different things so we can identify what's going on in our program. Well, I think the solution might be, we know that somebody dies when they hit 0 or below 0. So maybe rather than that statement, maybe we could create it and say less than 0, or even less than or equal to 0. All right, so we could change that. So now we're going to click run, and it'll force us to save it, yes. And so now it runs through that program and exits. Now it doesn't tell us a whole lot and doesn't do a whole lot, but it just shows us how we can correct and how easy it is to make those kinds of infinite loops. So page 68 looks at how do we trace a program. Well, we can trace it by hand, so we, just like I did, each time we loop through there. We can create, like I did with this print health, so we can see what values are that we don't normally print. And so both of those are good ways to try to fix issues. And you are going to run into issues, unfortunately. I wish I could say that you're going to sit down and write everything and never have a simple issue, but small things. As you can see, leaving out the colon, trash behind when I copy and paste something or I delete something. So. So, there's some other things that we can do. So we can look at some odd comparisons. So I'd like to open up the maitre d program. We're going to edit that one so we can open it up. And we're going to look at that. So we have a couple of things. So let's run it first and just see what happens. So we're going to run, welcome to the Chateau de Food. It seems we are quite full. How many dollars do you slip the maitre d'? Well, let's slip him a 10. I'm reminded of a table right this way. Okay. So what it's doing is asking a question. And the reality is we're doing something a little different. So we have our print statements. That's pretty common sense. And we have this statement here. So money equals input. So now we're combining a couple of things. So previously we might have done two variables. We might have taken in an input as a string and then converted it to another variable with the integer. Well, here we're doing a function inside of a function. And notice how that's pretty slick. We take the integer value of the input function, and so we're nesting two functions together. So that gives us then money equal to the integer value of whatever we put in. Quick, easy way to do that. But then we have an if statement. And the if statement says if money. If money. Huh. So what does if money make? I mean, why would we do it this way? It's kind of short, it looks pretty easy, but what we're really saying is if there is any value other than 0 in money, it's going to create a true. It's going to evaluate to true. Else, it's going to be false. Now, it can do some funny things. So if I run this, how many dollars do you slip the maitre d'? -10. So -10, well, you have to think about what's going on here. Because it takes the integer of that, it's still going to be an integer value, and it's still going to evaluate true. Now, obviously, we can't hand him negative money, but it just shows how that evaluates. So that's another way we can look at conditions. What we're really saying is, if there's anything in there, we're going to create this. Now, we could certainly do it where if money is greater than a certain value, so we could put the maitre d' as greedy, but it's just another way to evaluate some of these conditions. So I know that's kind of an odd way to look at it, but we're looking at other ways to evaluate conditionals. So I think the time here. Okay, so one last thing here we're going to look at. We do have some ways to break loops inside of our program. Now, this is interesting. I'm not as big a fan of this, but it's an interesting method. So I'm going to look at finicky counter, and I'm going to edit it so I can see what's going on. So we actually intentionally create an infinite loop with this program. So what this program does, and let's run it and I'll show you. So it counts 1 to 10. But is there anything wrong with that listing of 1 to 10? It's missing a 5. Okay, so it's missing 5. So let's see what happens and why that works. So the first thing we're going to do is we have a sentinel value called count, and we set it equal to 0. So that's just good practice. We set our sentinel values equal to whatever we want to start at. In most of the case, it's 0. And while true, so do we have any value for true? So this is going to run forever because we're going to essentially evaluate a condition as positive, or so this loop here is going to run essentially forever. So we have two pieces in here. So the first thing we're going to do is We're going to add 1 to count every time it runs. So every time this loop runs, it adds 1. And we're going to add an if statement here. So if count greater than 10, break. And that break kicks us out of this loop. So that will kick us out of the loop. And then we have a second if statement. If count equals 5, continue. Okay. If count equals 5, continue. So this statement then forces that loop to go back to the beginning of the loop and doesn't hit the print statement. So it's demonstrating a couple of different things. So continue means jump to the back of the loop or the beginning of the loop, and break means exit the loop. So we can use something like this not only as a tool here to kind of make an interesting counting program, but we can also use that as an escape clause. So we create a loop. We could use something like this as an emergency escape. So good practice says we're not going to create any conditions that create an infinite loop, but we can use a tool such as this to get back out of there if you need to. Now, it's not necessarily good programming practice, but it gives us another tool to escape out of there. So we could certainly create this to go to 100. I could then run it, and it runs to 100, and notice it skips the 5. Yes, I want to exit it. So it's just another way we can create a loop and some kind of conditions inside of that loop. We can either do this continue, which is kind of an interesting piece, and we do use this fairly common. It allows us to skip parts of that loop inside. So if I think about our game or something else, it allows us to keep that game running, but skip doing some conditions. So page 73 talks about that. We will start on Thursday with looking at compound conditions. In other words, how do we combine multiple statements so we can have 2 conditions possible? So I need count equal to a value and something else. And it's something we do pretty commonly on our own conditions. So make sure you work along and have practiced to this point. We will continue the rest of the chapter and look at your homework a little bit on Thursday.